So let's go over in our skills practice 6.7. I'm going to talk to you guys about the binomial theorem, and we'll see how complicated that looks like, and then we'll just use the Pascal's triangle. So what is the binomial theorem? Well, if I ask you to do something like this, x plus 2, how many times do I have to write this x plus 2? What number's up here? There's a 1. So your answer would just be x plus 2. Now you can see it. So you just write it out one time, right? Now, if I wrote x plus 2 squared, class, does that equal x squared plus 2 squared, which is 4? No, the answer is no. They're not equal because you would actually write this out twice. And if you write it out twice, then you would do the box. And then if you did the box, it would come out to be x squared plus 4x plus 4. Right? Do you want to see it? You trust me? Okay, trust me. So what happens if I said x plus 2 to the 4th power? Would you want to put the box and then do another really big box and then another really big box? No. That's a lot of work, isn't it? Or if I said expand it to the 24th power, you would be doing that probably a long time, right? So they developed something called the binomial theorem. Let's copy down the binomial theorem. So again, the binomial theorem will just be a faster way instead of doing the boxes. You will be given, and in the form of a plus b to the n power, n choose 0, a to the n, b to 0, plus n choose 1, a n minus 1, b 1. And if you notice what's happening, the a values are counting down. You know they're counting down by the subtraction of 1. And the b values are doing what? They're counting up. Until you get something that looks like something really crazy. Can I make it bigger? This is the biggest it can go. Feel free to use manual zoom. A to the 1, b to the n minus 1. Plus n choose n, a to the 0, b to the n. Now, there's a whole lot of math that we haven't even learned in this class. We have not learned that this is essentially combinations. And I don't need to take another couple of days to teach you combinations, and then we come back to the binomial theorem. And this looks kind of complicated, doesn't it? Yeah. Math doesn't look nice when there's a bunch of letters. So, here's the great thing. They have created something called Pascal's triangle. And we're going to create Pascal's triangle together. To do that, I'm going to draw a bunch of lines. Draw about maybe 10 to 15 lines. If you have a straight edge, super helpful. Your life will change because rulers draw straight lines. Draw a couple of lines there. How many we got there? Alright, so let's zoom in over here and let's create this Pascal's triangle together. And the first number you're going to start with is a 1. And basically, the 1s kind of slide down the triangle on the left and the right. So now we're going to draw another set of 1s. And then in the next row, the 1s still keep sliding, but here in the middle, pay attention here, you add them together. What math operation, class? 1 plus 1 is 2. So in the third row, I have 3 numbers. Let's create the fourth row together. Class, what number am I going to write? 1. And then what do you do with those 2 numbers? Add, and when you get 3, add those 2 numbers together, you get 3, and you slide that one down, you get 1. Now, over here, I want to write that this is called the nth power. And the nth power, I'll explain later, but this represents 0. And then this is the first power, second, and we'll just write all these numbers down. We're going to go down to 13. So, let's break this up. When I say the word go, partner B, I want you to explain to partner A how to get the fourth row. Leave your desk next to your partner. You guys have 20 seconds. Ready, set, go. Or bathroom. You can move back with Brenda. Jesse, move back there.
Okay.
Okay. What number did you guys get? What goes here, class? 1. 1 plus 3 is 4. 6. 4. 1. Raise your hand if you got that. So again, the 1 slide on the side, and then you just add those numbers, right? This number plus this number, this number plus this number, this number plus this number. Okay? Alright, this is what you guys, the fun you get to do now. You get to do that all the way down to the 13th power. Take a couple minutes to do that. Ready, set, go. Okay, Ethan, help us get this next row.
So 1, 5, 10, 10, 1.
Oh.
5, 1.
4 plus 1 is? 5.
I did this wrong.
Oh, yeah.
So we're supposed to be adding these. You guys see that?
Me too. I forgot to put 2 tens.
Thank you, Katham. Now, feel free to put this on your formula sheet, or if you're an awesome student, you can just derive it when you see it on your quiz or test. Jason, the next row.
1, 6, 15, 20, 15, 6, 21.
Good job. John R.
What is that, 7?
So,
1, 7, 21, 35, 35, 21, 7, 1.
good job. Rafi.
1, 8, 28, 56,
56, yeah.
70,
Yeah.
8. Oh, 8.
There you go. Marie Bellin?
1, 9, 20. No, I got that line wrong.
Okay, do it right here. 8 plus 28.
36.
Yep.
84.
Yep.
126.
Yes.
126.
Yes.
84.
Yes.
36.
Yes.
9. 1.
Good job. Leslie.
What? 10. 45. Wait, then I get
Mm-hmm.
36 plus 84.
120.
84 plus 126. 210. 252.
210.
Look at your numbers over there.
120. 45. 10.
Oh no, running out of space. Let's use a red pen. Thank you, Leslie. Casey.
Okay. 1, 11. Am I adding 10 and 45 together?
Correct?
55.
Uh-huh.
165.
Keep going.
330.
That's
462.
And you can just look at your numbers now on the left side.
330. 165.
That's 165.
55. 11 and 1.
Wait, what? 252 plus 210 is 330?
Yeah, that's what I know.
Oh, I know what happened. There's only 462 in there, huh?
Oh.
That was my fault. Is that right?
Yep.
Kind of messy. We're getting there. All right, 2 more rows. Kiana.
1.
Wait. 1.
12. 66. 220. 495.
How much?
495.
495.
792. 924.
Echo?
924.
Wait, 4, 7, and then
462 up there.
oh, got it. You're right. How much was that?
495. 220. 66. 12.
Whew. Good job. All right, last one, just for you. Jesse. A.
13.
13 or 1 and 13. 78. 286. 715. 1,287.
1,287.
1,760.
'Keep going.
1,760 again.
Yep.
1,287.
Yep.
270.
220.
715.
'Just get the numbers over there. Yeah. 2 what?
285.
6.
76.
78. 13 and 1. Woo! Oh. Okay, so I know that seemed kind of painful, but at least it's a good reference so we can do future problems.